Hello viewers, this is Jessel here with you today. Um, it's been a while, and I came today because there had been this little thing, a problem that one of my students kind of gave me, or a friend kind of gave me to solve, and here is it. So carefully extracting the question would be like 2 raised to the power of x raised to the power of 2 minus 3x plus 2 raised to the power of x minus x raised to the power of 2 all equal to 2 raised to the power of 1 minus x. Right. With how we've seen this question, it's kind of is exponential, is an exponential equation, and if care is not taken, you might really be misguided or you might lose your steps. So carefully going through this, I feel like maybe I should take you to the board where you could see how these things are solved. Right, so let's rush first to our board, of which I'm excited to teach. Okay, yes, the question is already there, and let's dive right in. So, like as it is from the original question, we all know. So first, we would like to observe a few things, like the laws of exponentials. I vividly do remember this one where we could say index notation of the same base whenever they are dividing, the powers are subtracted. So someone who is familiar with exponents would understand this. So this is the first law. And looking at each and every of this having negative, like negative 3x as power, and also negative x squared on the second term, and then on the other side of the equality sign we have negative x as power. So we are going to resolve this to the laws here, which would mean 2 raised to the power of x raised to the power of 2 all divided by 2 raised to the power of 3x plus 2 raised to the power of x all divided by 2 raised to the power of x squared plus, alright, sorry, that wasn't intended. That should be equality sign now. So um okay, back on track. So we have equal to 2 raised to the power of 1, then 2 raised to the power of x. I would love to balance this equality sign, this equation, and first thing that came to my mind was let us multiply through by 2x. Let us multiply through by 2 raised to the power of x, the one on the um, right hand side of the equation. So that would mean um, 2 raised to the power of x. I'm multiplying through all in a bracket 2 raised to the power of x squared all over 2 raised to the power 3x all bracket close plus 2 raised to the power of x all in a bracket. I'm just being careful so that you don't lose my steps. 2 raised to the power of x squared equal to, alright, 2 raised to the power of 2 raised to the power of x, then 2 raised to the power of x. This gets to cancel this, leaving the equation with just what we have here. Now, if I were to say, I would be like, okay, we already know that these are index notations multiplying, And there's one crucial law that we all should remember, that when index notations of the same base are multiplying, say a raised to the power m times a raised to the power of n, the powers are meant to be added, so we have here m plus n. If this is very clear, that means we would have to go over to the next, which would be me resolving this. So firstly, I'd like to take this back to the original way we saw it, or at least give you what the outcome of this multiplication would be. So I have here equal to um, 2 raised to the power of x raised to the power of 2 minus 3x, then you could say plus x by virtue of the multiplication of 2 raised to the power of x. And then I can now say for the middle term or for the second term, plus we have here 2 raised to the power of x minus x squared plus x by virtue of the multiplication of 2 raised to the power x as we know it, and on this other hand by virtue of the cancellation we just have 2. So here we collect like terms of powers. So collecting like term for powers would be 2 raised to the power of x to the power of 2. 3x plus 2x would give me minus 2x. And then I have here plus, I have here x plus x would give me 2x minus x squared. So I have here 2 raised to the power of 2x minus x squared all equal to 2. So the next thing we'll be looking at is identities. How or what is common here? I'm sensing some kind of here commonalities. This is just like a side note. Commonalities here would be 2 raised to the power of x 2x. Alright, so just watch the board. So these are the commonalities I see here, but in this case it's more like there is a work that needs to be done. So let me take the power for this term. I'm taking the power for this term, which I underlined, which taking power of the second term, which we know is 2x minus x squared. In this case, I could say this is also equal to negative all in the bracket x squared plus minus, let me clean this, minus 2x all bracket close. So if this is the same thing as this, I might want to substitute it, which we now have. Therefore, we now have 2 raised to the power of x to the power of 2 minus 2x plus 2 raised to the power of negative all in the bracket x to the power of 2 minus 2x bracket close equal to 2. So in this case, I think the first term exponent and the second term exponent are alike. But here we recall the law of indices, negative exponent, law of negative exponent, recall law of negative exponent, which has that a raised to the power of negative m is the same thing as saying a raised to the power, alright, or you could say the reciprocal of a to the power of m. So at this point, I'm going to do that for the second term, which would mean, alright, I hope that this part of the book contains it. So I have here 2 raised to the power of x to the power of 2 minus 2x plus the reciprocal of 2 to the power of x to the power of 2 minus 2x, all equal to 2. So I could say commonalities. Let the common term 2 raised to the power of x to the power of 2 minus 2x be equal to p. That would mean, therefore, p plus 1 over p is equal to 2. So multiply through by p, so I would have here p squared plus 1 equal to 2p. That's what we get. So I rearrange. This is looking like a quadratic equation. So I have here p squared minus 2p plus 1 is equal to 0. So this is it. It's a perfect square, of which by convention I wouldn't be teaching quadratic equations here. We all know that if this is a perfect square, p is therefore equal to 1 twice. If you want explanation of how p became 1, maybe you'd want to stick around for my quadratic equation class, and I would give you clarity. But here p is equal to 1 twice. For every quadratic equation we expect 2 answers, and this is it, 1 twice. If we could recall, since p is equal to 1, we could say recall what p used to be, which is recall that p is equal to 2 raised to the power of x squared minus 2x. So I'm replacing it. Therefore, we have that 2 raised to the power of x to the power of 2 minus 2x is equal to 1. So we recall that anything to the power of 0 is equal to 1. So I would say 2 raised to the power of x squared minus 2x is equal to 2 to the power of 0. So I could say equating powers, equating powers. So at this point, I could easily say, all right, okay, I can say this part of the board. So I'm just going to do this. If I were to equate powers, that means we have, therefore, x to the power of 2 minus 2x is equal to 0, of which I can factorize the left hand side of the equation, and then this is the right hand side. If I were to factorize it, it would be x all in a bracket x minus 2 bracket close equal to 0. So at this point, we know that it's a quadratic expression where x is either equal to 0 or 2. Final answer. So all these things are very necessary for your recalling, and I hope that you understood it. So meanwhile, you could equally, since x is equal to 0 or 2, meanwhile you could use the graphical method to represent or solve this problem, as the case may be. So if I were to take you down to a calculator where you input the question or the problem as it is, this is what you get. So on this other side of the equation, on this other side of my screen, you could see the equation as properly represented. And then here, it tries to tell us that x equals 2. as the case may be. It didn't show the part where x could be equal to 0. But then, if I were to say this is enough, so that is it for you. Um, Meanwhile, I do hope. Okay, I still think there are two lines generated here. A green line, two green lines. We know that the axes are always in black ink, but here we have two green lines on the zero axis, on the 0 point of zero, and then on the 2. So that is that for you. Meanwhile, this is very incredible, and I really, really do love it. Sometimes it seems like the graphical method are very easy, and they are easy to go with, and it is very understandable. So let's go through our work once more. I just hope that there is clarity achieved here, and yes, I hope we talk more. For those of you who didn't understand what we did or how I got to p equal to 1 twice, this is a quadratic equation, and I hope that maybe on our next class we would x-ray it and see where you have lapses. I would really love to take you on a class for it. So this is that for you. Join me, follow me on my Facebook account. I do have a YouTube account, but if we start talking very well on this account, or follow as you follow me, I would ensure that yes, you get every of my medium to reach out. So is all this we do here. I hope to see you soon and do have a blessed day. Bye bye.